Hello everyone, we are group PPGHR. My name is Hou Zuoliu.
My name is Jihao Xu.
My name is Ziyuan Li.
Our project is to build a heart rate and respiratory rate signal detector. Our system can detect the heart rate and respiratory rate signal from a human body and can calculate the heart rate and respiratory rate frequency. Now, let's introduce you to how our system works.
Now I'm going to show how our system monitor heart rate and respiratory rate. We can see from the LCD, as I put my finger between LED and the phototransistor, the system starts working. The first line of our LCD shows my heart rate, which is 81. And the respiratory rate need a longer time to processing. We need to wait a second. Now it shows my respiratory rate in the second line of our LCD. That's all how our system working, and thanks for watching. For detailed information about our project, please check our website. Thank you.
We can do the comparison between the professional device and our PPG chip for heart rate signal. We can see the result of heart rate signal in the top line of the professional device and on our LED screen. We can see the results are very similar. It is about 90 BPM. The yellow line is the input signal detected by our sensor. The green line is the output signal from the buffer, which is next to the heart rate comparator. So this is the heart rate system. And we can see the period of filtered heart rate signal is about 0.5 seconds. The yellow line is also the input signal. The green line is the output signal from respiratory system. We can see the period of filtered respiratory rate signal is about 5 seconds.
The basic principle of PPG is shown by this photo. Since the blood volume in the vein is periodic as it is caused by heartbeat and respiration, the volume of light passed through the finger will change, and the photodetector will transform the change of volume of light it receives into electric signal. This picture shows all the components of our system. Basically, our system is composed of a sensor, a signal processing chip, and Arduino board. The sensor is composed by infrared LED and a photodetector. The sensor will output a weak voltage signal that includes heartbeat, respiration, and noise information. After receiving the signal from sensor, our chip will carry out signal processing. This picture shows the components of our chip. It has two paths for input signal. The upper path is for heartbeat signal. It is composed by two low-pass filter, two high-pass filter, two amplifiers, and a comparator. These components will filter out heartbeat signal and amplify it till it is significant enough for comparator to transform it into real-to-real digital signal. And this digital signal will be sent to Arduino board for further signal processing. The lower path is for respiratory signal. We simply double the number of each components in heartbeat signal path. This is because respiratory signal is very weak, thus it needs more filtering and amplification. This photo shows the chip structure in detail. You can see that this is the path for heartbeat signal. And this is high-pass filter, this is high-pass filter, and this is low-pass filters with amplifiers. Also, as you can see, the lower path is for respiratory signals. This part is current mirror. It uses reference current to generate specific DC current for each OTA and the comparator to use in our chip.
I will introduce how our system captured the signal. The input signal was captured by one infrared LED and a phototransistor. As user put finger between LED and phototransistor, the system will capture the input pulse and start working. Then the resistor and the capacitor here are our off-chip low-pass and high-pass filter. As phototransistor capture the input signal, the high-pass and the low-pass filter will filter out the DC and the disinterested signals and send the signal to our chip. As we can see, here is our chip. The chip including 6 OTAs, 2 comparators, and 2 output buffer. The OTA are used to amplify the signal and send it to the comparators. The comparator are used for transfer the analog signal to digital signal for our Arduino board to processing. The output buffer is used for providing more driving strength. This part is our LDO. It was used to convert a 5 volts voltage to 1 volts for our chip to working. The Arduino board here have 3 functionalities. First, it was used for our digital signal processing. Second, it can provide a 10 volts DC voltage and convert to 5 volts as our LDO input voltage. Finally, it also used to drive and send the processing result to our LCD screen to display the heart rate and respiratory rate.